Hello everyone, welcome you all to another video on matrix. In this video we will look into how we can find the inverse of a 3 by 3 matrix. In the previous video we have seen what the inverse is and how we can find the inverse of a 2 by 2 matrix. We have also seen what a cofactor, what is a minor of a matrix. Okay, so in this you will be solving or we will be finding the inverse of 3 by 3 matrix. There are 3 rows and there are 3 columns. We have also seen that inverse is possible only for square matrices. So first we have to check whether the given matrix is a square matrix or not. If it is not a square matrix, then it is no use of proceeding further. So if it is a square matrix, then we have to check whether the determinant is 0 or not. If the determinant is 0, inverse doesn't exist. However, if it is not equal to 0, only then inverse will exist. So here at the very beginning we have computed the determinant for A. So what is the determinant of A? So 1640, 1 multiplied by 1640, determinant of this, minus 2, excluding this row and excluding this column, it is 0540, determinant of this we have to find, and plus 3, 0516. So this is the process of finding the determinant of A. So we have computed, after the computation we have seen it is equal to 1, it is not equal to 0. Since it is not equal to 0, therefore inverse exists. Now we have to find what the inverse is. So I will solve step by step and try to explain each and every step while solving so that it becomes more and more clear. So first we have to find the cofactors. So first we will find the cofactor for row 1. So what is the row 1? 1, 2, 3. These are the elements, and 1, 2, 3. So these are the row numbers. So first we will find the cofactor for 1. That means how we have to do this C11, C11. So this is the formula for cofactor. It is minus 1 to the power 1 plus 1 and the minor of 1. What is the minor of 1? Exclude the first row, exclude the first column, and what is left? 1640. So we have to find the determinant of 1640. So what value we will get from this? It will be minus 1 square means it is 1 and 6 minus 4, 24. So sorry, 10 is 0, 0 minus 24 is minus 24. Similarly, we will find cofactor for 1, 2. So it will be 1 plus 2. So whenever we are finding cofactor for 1, 2, that means we are finding the cofactor for this element, 1, 2 for this element. Whenever we are finding for this element, we have to exclude this column and this row. So we are left with 0540. So 0540. So after calculation, we will get it to be 20. I am not going into the details calculation. So it is minus 1 cube means minus 1, 0 minus 20. So minus 1 into minus 20 is 20. Similarly, C13 will be equal to minus 1, 1 plus 3, then 1 and 3. So here we are finding the cofactor for 3. So exclude this row, exclude this column, it will be 0156. Choose 0156. So after computation, we will get the value minus 5. So this is for row 1. Next, we will find for row 2. So it will be C21. So row 2 means we are finding the cofactor for 0. So finding the cofactor for 0 means we will eliminate this row and this column. So we are left with 2630. So it will be minus 1 to the power 2 plus 1 and 2630. 0. I'm just repeating it once again. We are finding the cofactor for 0. So we have to exclude this row, this column and this row. So it will be 2, 3, 6, 0. So after computation, we will get the value to be 18. Next is C2, 2. That means we are finding the cofactor for this element, 2, 2, this element. So exclude this row, exclude this column. It will be 1, 5, 3, 0. So it will be 1, 5, 3, 0. So it will come out to minus 15. And C2, 3. C2, 3 is this element. So the cofactor will be minus 1, 2 plus 3, 2, 3. So this element, so the minor will be exclude this row, exclude this column. It will be 1, 2, 5, 6. So 1, 2, 5, 6. So after computation, we'll get 4. So till now we have found the cofactor for row 1 and row 2. Similarly, for row 3. For row 3, it will be C3, 1 minus 1 to the power 3 plus 1 means we are finding for this. So we have to exclude this row and this column. It will be 2, 1, 3, 4. Minor is 2, 1, 3, 4. So after computation, we will get the value 5. C3, 2. Similarly, 3 plus 2. 3, 2 means we are finding for this element. So it will be 1, 0, 3, 4. 1, 0, 3, 4. Just do the after we do the computation, we will get it to be minus 4. Similarly, C3, 3. 3 plus 3. This 3 plus 3 is 3 plus 3. For this we are doing, so we will exclude this row, this column. It will be 1, 0, 2, 1. So it is 1, 0, 2, 1. So after computation, we will get it to be 1. So we have found the cofactors for all the elements of the matrix. Therefore, the cofactor matrix C is equal to, for the first value, it is minus 24. Similarly, 20 minus 5. So we will just put it 24, 20 minus 5. Next is 18 minus 15, 4. 18 minus 15, 4. And the last row is 5 minus 4, 1. So this is the cofactor matrix. From this cofactor matrix, we have to find the adjoint matrix. So adjoint matrix is nothing but the transpose of the cofactor matrix. Therefore, adjoint of A, the actual matrix was A. So adjoint of A is equal to transpose of this. So it will come out to, transpose means the row elements will go to the column elements will go to the row. So 24, 20 minus 5, 18 minus 15, 4, this, and last this one, 5 minus 4, 1. So this is the adjoint of A. So till now what we have got? We have got the determinant is there. We have found the cofactors for the 3 rows. We have found the cofactor matrix. By taking the transpose of the cofactor matrix, we have found the adjoint matrix of A. Finally, the inverse we can find. The inverse will be A inverse equal to 1 by determinant of A, which is 1, and the adjoint of A. So adjoint of A is minus 24, 18, 5, 20 minus 15 minus 4 minus 5, 4 and 1. So 1 by determinant of A, which is already 1, we have computed this, and multiplied by the adjoint matrix. So finally we will get the reverse matrix is 1 by 1 is 1 only. So minus 24, 18, 5, 20, minus 15, minus 4, minus 5, 4, 1. So finally this is the inverse of the given matrix A. So this is the way of finding the inverse of a given matrix. So I hope the concept is clear. We have to just remember these things, that whenever we have to find inverse, we have to first find the determinant. If the determinant is 0, then no question of further proceeding, because determinant of 0 means it is a singular matrix, and since it is a singular matrix, so inverse doesn't exist. However, if it is not equal to 0, then we have to find the cofactors. Based on the cofactors, we will generate the cofactor matrix. Transpose of that cofactor matrix will give us the adjoint matrix, and that adjoint matrix divided by the determinant value will give us the inverse of that particular matrix. So with this, I hope the concept of finding inverse is clear. In the previous video, as we have seen 2 by 2 matrix, here we have seen how we can find inverse of a 3 by 3 matrix. So with this video, so we'll conclude here. In the next video, we will look into how you can perform other operations on matrix. Thank you very much.